In the boundless void of space, the question that has captivated humanity for centuries remains as compelling as ever: are we alone? We've looked up to the stars for millennia, marveling at the vastness of the universe and wondering whether there could be other worlds out there, similar to ours, perhaps even brimming with life. Our search for answers has come a long way since the days of early astronomers peering through rudimentary telescopes. Today, we stand on the precipice of a monumental breakthrough in our quest for extraterrestrial life, all thanks to one of the most powerful instruments ever created, the James Webb Space Telescope, JWST. Launched in December 2021, the JWST is the latest and most advanced space telescope to date, designed to peer deeper into the cosmos than any of its predecessors. It is an engineering marvel, a feat of science and technology that has already begun to reshape our understanding of the universe. This cutting-edge telescope is capable of investigating exoplanets, planets that exist outside our solar system, in ways that were once the stuff of science fiction. Using its highly sensitive spectrometers and infrared instruments, the JWST is able to analyze the atmospheres of distant planets, searching for key signs of habitability and, potentially, life. The primary goal of the JWST is to explore the cosmos in ways that were previously impossible. For years, astronomers have been searching for planets that are similar to Earth, worlds that are the right size, at the right distance from their star, and in the right conditions to potentially support life. While the search for Earth-like planets began long before the JWST, it is this telescope that has taken the hunt to a whole new level. The JWST's powerful infrared capabilities allow it to peer through the thick clouds of gas and dust that obscure distant planets, revealing their composition, atmosphere, and other vital signs. This capability is crucial in the search for life beyond Earth. To detect life on another planet, scientists look for biomarkers, specific chemical signatures that could indicate biological activity. Water vapor, oxygen, methane, and carbon dioxide are among the key biomarkers scientists seek. These gases, when found in the right conditions, can be a telltale sign of life. For instance, on Earth, oxygen and methane are often produced by biological processes, particularly by plants and animals. The presence of these gases in the atmosphere of an exoplanet could suggest the existence of life forms. And that's exactly what the JWST is designed to do: look for these biomarkers across the universe. What makes the JWST so revolutionary is its ability to detect these signs from planets that are light years away. It is able to capture the faintest signals from distant stars and planets, even when they are located far beyond the reach of any other telescope. Through its finely tuned spectrometers, the JWST can analyze the light emitted by distant planets, revealing the chemical makeup of their atmospheres. This process is known as spectroscopic analysis, and it's one of the most powerful tools in the search for life beyond Earth. The discovery of exoplanets, planets orbiting stars outside our solar system, has been one of the most exciting developments in astronomy over the past few decades. In fact, the discovery of the first exoplanets in the 1990s opened up a new era of space exploration. Prior to that, it was believed that our solar system was unique, the only one in the galaxy to contain planets. But as astronomers began to use more advanced techniques to study distant stars, they discovered that planets were far more common than anyone had imagined. Since then, over 5,000 exoplanets have been discovered, with many more being identified each year. Some of these exoplanets are similar in size and composition to Earth, and they orbit stars in what is known as the habitable zone, the region around a star where conditions are just right for liquid water to exist on a planet's surface. The presence of liquid water is considered one of the key factors for supporting life. Water is not only essential for all known forms of life but also plays a critical role in the chemistry of life itself. The discovery of water on an exoplanet is therefore one of the most exciting signs that life could exist on that world. And the JWST is particularly well suited to detect water vapor in the atmospheres of distant planets. One of the most significant discoveries made by the JWST so far is the detection of water vapor on a planet called K2-18b. This exoplanet, located approximately 124 light-years away, is about 2.7 times the size of Earth and 8 times its mass. It orbits a red dwarf star, a type of star that is smaller and cooler than our Sun. K2-18b lies in the habitable zone of its star, meaning that it is at just the right distance for liquid water to exist on its surface. The discovery of water vapor in its atmosphere is a major breakthrough in the search for life. If liquid water is indeed present on K2-18b, it could provide the conditions necessary for life to thrive. Scientists are particularly excited about K2-18b because it could be a potential candidate for further exploration. If the planet has oceans or even continents, it could be a world that bears striking similarities to Earth. Researchers are already imagining what such a world might look like: a blue-green planet with vast bodies of water, possibly home to life forms. Could there be microbial life in the oceans of K2-18b? Or even more complex life forms? These are questions that the JWST's continued observations will hopefully help answer. The search for life on other planets doesn't end with K2-18b. In fact, the JWST has already begun to identify other promising exoplanets that may harbor the conditions necessary for life. One of the most fascinating possibilities in the search for extraterrestrial life is the discovery of super-Earths. These planets are similar in composition to Earth but are larger and more massive. Because of their size and mass, super-Earths could have more stable atmospheres and a greater ability to retain water, making them prime candidates for life. Some super-Earths, like K2-18b, are located in the habitable zone of their star, where the conditions are just right for liquid water to exist. Others, however, are located in more extreme environments, where the conditions for life may be more challenging. Regardless, the JWST is enabling scientists to study these planets in greater detail, revealing not only their potential for habitability but also their atmospheric composition and climate. By studying these worlds, scientists hope to learn more about the range of conditions under which life could exist, and whether those conditions are more common than we think. The JWST's ability to study the atmospheres of distant planets is a game-changer for the search for life. By examining the chemical composition of these atmospheres, scientists can detect gases that may be produced by biological processes. For example, on Earth, oxygen and methane are both produced by living organisms, so their presence in an exoplanet's atmosphere could be a strong indicator of life. Of course, there are other possible explanations for the presence of these gases, such as volcanic activity or chemical reactions, but the fact that we now have the technology to detect them in distant exoplanets is a monumental step forward. The JWST's capabilities extend beyond just studying the atmospheres of exoplanets. The telescope is also capable of detecting artificial light on distant worlds, which could be a sign of intelligent life. This ability to look for artificial light is one of the most exciting features of the JWST. While no artificial light has yet been detected on any exoplanet, the possibility that it might one day be found is thrilling. It would provide definitive proof that an advanced, technologically capable civilization exists on another planet. Of course, the search for life on distant planets is not without its challenges. Many exoplanets are located hundreds or even thousands of light-years away, making it difficult to study them in detail. Furthermore, exoplanets are often small and faint, making them hard to detect in the first place. The JWST, however, is capable of overcoming many of these obstacles. By using its powerful infrared instruments, the telescope can detect even the faintest signals from distant worlds, revealing their secrets in ways that were once thought impossible. One of the most exciting prospects in the search for extraterrestrial life is the possibility of finding Tatooine planets, planets that orbit two stars, much like the fictional world of Tatooine from Star Wars. These binary star systems are actually quite common in the universe, and some of the planets that orbit them are located in the habitable zone, where conditions could be right for life. The JWST is particularly interested in these Tatooine worlds because they could present unique environments that differ significantly from our own. For example, these planets might experience long periods of daylight and night, depending on the configuration of the two stars. This could result in unusual climate patterns and possibly even strange forms of life. the JWST is already uncovering new and exciting possibilities in the search for life beyond Earth. As its observations continue, it is likely to discover even more exoplanets with the potential to support life. With each new discovery, we come closer to answering one of the most profound questions humanity has ever asked: are we alone in the universe? The knowledge gained from the JWST will help us answer this question, and it may even open up the possibility of discovering new forms of life that we have never imagined. One of the most remarkable aspects of the JWST is that it is not just helping us search for life on other planets, it is also providing us with a deeper understanding of the origins of life here on Earth. By studying the atmospheres of distant planets, scientists can learn more about the conditions that led to the formation of life on our own planet. This could provide valuable insights into how life might arise on other worlds, and what conditions are necessary for it to thrive. The search for life beyond Earth is just beginning, and the James Webb Space Telescope is at the forefront of this exciting endeavor. As we continue to explore the universe, we are on the cusp of discovering new worlds and perhaps even new forms of life. The possibilities are endless, and the discoveries yet to come could forever change our understanding of the universe and our place within it. The James Webb Space Telescope is not just a technological wonder, it is a gateway to the future of space exploration, and it is opening our eyes to a universe full of mysteries waiting to be uncovered.